Good evening students, how are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform BYJU'S Exam Prep. This is our YouTube channel for ECE Electrical branch. Students, am I audible to all of you? I just want to know, am I audible to all of you? All of you must respond. Is audio and video all fine? Great. So let's proceed. Thank you, Raghuram. Chaliye, let's start. Let's start. Just a moment. So meanwhile, students are commenting regarding the topics of engineering mathematics. So students, I will check whether there is bandwidth of taking up these sessions or not. If yes, I will inform you in my Telegram group and will definitely arrange sessions for multiple integrals and complex variables. Okay? Yeah. Chali. I think all fine. I can see Krishnaveni. How are you, Krishnaveni? Ashok, good evening. Is also there. What's your name? Chinmay Roy is also there. Stay tuned for the best of the concepts. See, Super 11 doesn't mean that I would have brought some difficult questions. No. So the areas wherever I feel that these questions are important, or these areas are important, on those areas we have taken the questions. We have selected the questions. I'm fine, beta. Don't panic, Raghuram. It's just hold your feelings, hold your nerves, and definitely you can do miracles. We have belief on you. Karthik Iyer, good evening. Am I audible to everyone? क्या आप मुझे सुन पा रहे हैं? Is audio and video all fine? All fine. I'll start the session now. So students, in this series for Super 11 series, yes, today's topic is signals and systems. So I have brought 11 questions from the subject signals and system, whichever I felt that these are the best questions. Yeah. So students, this is the brief introduction about me. I have been teaching in GATE ECE domain since many years, and my subjects of interest are engineering math, signals and system, and analog circuits. Yes, Ashish Kumar, thanks for your response. Thanks Raghu. Thanks everyone. So students, I will just hide myself so that you would be able to see the entire screen. You can see the legendary faculty Sanjay Rathi sir on the screen. Students, I just want to inform you that on 31st of Jan, sir will be coming live at 7:30 p.m. on BYJU'S Exam Prep. Yes, this is our app. So on our app, on BYJU'S Exam Prep app, Sanjay Rathi sir will be coming up live for a perfect strategy for GATE 2024 aspirants. So students, it is a humble request from my side that you should just reveal this information in all your juniors, among all your juniors. So Ravi Shankar Kirti, good evening, bacha. How are you? Hello Malai, good evening. Then there is big announcement for you, students. Yes, all my dear students, don't miss out this session. This session is going to happen tomorrow. The timing will be 10 a.m. and we are coming up with 111 top questions on engineering maths and general aptitude. Yes, of course, verbal ability will be also there. So you can see on the screen, me and Sridhar sir will be taking up engineering maths. This time Rakesh sir will be taking up general aptitude, and yes, as usual, and your favorite Ashutosh Saxena sir will be taking verbal. So don't miss out this. Tomorrow 10 a.m. Tomorrow 10 a.m. It's not 30, this 31st is about the this ACE GATE 2024. This is about the workshop. I'm talking about this one. So this is tomorrow, 30th of Jan, Monday. Book your calendar for this. Got it? Let's proceed. 10 baje se. It will be starting around 10. It will be concluded by 2, I guess, in the afternoon, 2 or 2:30. So students, let's proceed. And here comes your first question from Super 11. So students, Super 11, as I told, does not mean that it will be something difficult, but Super 11 means the hot topics, hot areas where we can expect questions. So this is an important part. Each and every question is relevant, important here. So students, I will give you some time to solve this question. Yes. So signal x of t cos 200 pi t plus 3 cos 180 pi t is ideally sampled at a frequency of 150 Hz and passed through a unit gain low pass filter with a cutoff frequency of 110 Hz. What frequency components will be present in the output of the low pass filter? So student, what happens? See the logic here. This is a sampler. So x of t is first sampled. Then this sampled signal is further passed through a low pass filter. Low pass filter's cutoff frequency will be what? Low pass filter's cutoff frequency is 110 Hz. 110 Hz. Okay? Yes, sir. And this is the output, say y of t. So students, which all frequency components are there in the input? So input signal is having frequencies f1 equal to 200 Hz, not 200 pi divided by 2, this will be 100 Hz, and f2 will be 180 pi divided by 2 pi, this will be 90 Hz. Okay. Yes, the sampler is characterized by a sampling frequency of 150 Hz. Sampling frequency of 150 Hz. Sampling frequency of 150 Hz. Okay. Yes. So students, first this x of t is sampled. With a sampling rate of 150 Hz. Then the resultant sampled signal is passed through a low pass filter whose frequency is 110 Hz. So you need to find out which all frequencies will be there in the output. So I am just waiting for your calculations. Yes, I am just waiting for your calculations. I need answers from all of you. Yes, come on. So student, you can follow this expression NFS plus minus FM. NFS plus minus FM. Okay, sir. So what is this FS? FS, sampling frequency, is given as 150 Hz. So 150 N. What is the maximum frequency component here? That is F1, that is 100 Hz. Okay. Now students, what happens if I put the values of N here? N equal to 0. So component will be 100. I am not writing here negative frequencies. So when I put N equal to 0, I am getting 100 Hz frequency. When you put N equal to 1, we will be getting 150 plus 100, that is 250. And 150 minus 100 will be 50. Okay. If you put N equal to 2, then what? 150 into 2 is 300. 300 minus 100 will be 200. 300 plus 100 will be 400. So just see the cutoff frequency. Just see the cutoff frequency. Cutoff frequency is 110 Hz. So 110 Hz will be allowing these two frequencies. Now see one more point. 150 Hz. 150 Hz. Now apart from this, one more frequency component is there, and since this signal is in the form of cosine waves Fourier transform will be in the form of impulses. Yes, so these are called as sinusoids. So if I consider 90 hertz frequency as well, in that case what you will get 150 and plus minus 90. Why are you writing below? So now I am considering 90 hertz also. So if I am putting n equal to 0, then this will be 90, or n equal to 1. 150 minus 90 will be what? 150 minus 90 will be 60, and 150 plus 90 will be 240. That is greater. So 150, 90 and 60. 100 hertz, 50 hertz, 90 hertz and 60 hertz. So 100, 50, 90 and 60 hertz. So these are the frequencies which can be the part of the low pass filter. So this low pass filter will allow all the frequencies which are less than or equal to 110 hertz. Comfortable with this? All my dear students, respond fast. So this is the logic. Now see here, if this would be band limited signal, yes Raghu, if this would be band limited signal, then we would have considered the maximum frequency. But this is a sinusoidal signal, so both the frequencies can be the part of this calculation. Yes, so sampling frequency is mentioned here, 150 hertz. Sampling frequency is mentioned here. It is mentioned here, sampled at a frequency of 150 hertz. Raghu, sampling frequency is mentioned in the question. Comfortable everyone? Now student, this is the question for all of you. Match list 1 Fourier series and Fourier transform. List 1 is having Fourier series here means continuous time Fourier series, and Fourier transform here means continuous time Fourier transform. So match list 1 with list 2 and select the correct answers using the code given below. So student, yes, A is matched with what? So if you have continuous time Fourier series, what is the nature of its Fourier transform? Continuous time Fourier series. Continuous time Fourier series. What is its nature? What is its nature? Discrete and aperiodic. Discrete and aperiodic. So A is matched with 3. Discrete and aperiodic. Now, what about B? Continuous time Fourier transform. Continuous time Fourier transform. Yes, this will be continuous in frequency and aperiodic. Continuous and aperiodic. Continuous and aperiodic. So 4. Now, discrete time Fourier series. Discrete time Fourier series. This will be discrete and periodic. 1. Discrete Fourier transform. So actually it should be discrete time Fourier transform. Discrete time Fourier transform. This will be, yes, continuous and periodic. 3, 4, 1, 2. I'll show you all the options. Now the students, if you are not aware of the logic behind this, I can do it for you. So A3, B4, C1 and D2. A3, B4, C1 and D2. Option A is the correct answer. Now see here. This is time domain and this is frequency domain. So my signal x of t, if the signal is continuous time and aperiodic, we'll go for Fourier transform. Now we wait. So continuous time and aperiodic. So continuous changes to aperiodic and aperiodic changes to continuous. So when you take Fourier transform, it is continuous and aperiodic. Then if it is continuous time and periodic, then we go for Fourier series. Continuous time Fourier series. Continuous time Fourier series will be aperiodic. Continuous changes to aperiodic and periodic changes to discrete. So this is discrete and aperiodic. If it is discrete time and aperiodic, we go for DTFT. So DTFT, discrete changes to periodic and aperiodic changes to continuous. So DTFT spectrum is continuous and periodic. If you go for discrete time and periodic, then you have to use discrete time Fourier series. So discrete changes to periodic and periodic changes to discrete. So these are the various natures of frequency domain counterparts. So students, for continuous time Fourier series, what is the nature? For continuous time Fourier series, nature is discrete and aperiodic. Discrete and aperiodic. Got it? So A is matched with 3. Correct. Then continuous time Fourier transform. Continuous time Fourier transform, this one is continuous and aperiodic. Continuous and aperiodic. 4th. So B is matched with 4. Discrete time Fourier series. Discrete time Fourier series. It is discrete and periodic. Discrete and periodic. So 1. So C is matched with 1. Correct. Discrete time Fourier transform. Discrete time Fourier transform is continuous and periodic. Continuous and periodic. So D is matched with 2. Okay. So always remember this mapping duality table. See. Continuous signal changes to aperiodic when domain changes, and discrete signal changes to periodic when domain changes, and vice versa. If it is aperiodic, when domain changes it becomes continuous. If it is periodic, when domain changes it becomes discrete. So if you can remember this logic, you can solve this type of questions. Have you all got the logic behind this? No need to buy at anything. So A3, B4, C1, D2. Option A is the correct answer. Can I have your response? Ravi, whenever you solve the LTI equations, it is always advised to take their Laplace transform and solve them in Laplace domain. Now see this question. Students, see here. We are having a continuous time signal x of t as shown. Consider the following statements regarding the Fourier series coefficient Cn of x of t. See here. Signal x of t is having continuous time Fourier series which is denoted by Cn. Now see. We'll check. Student, now see this particular signal's graph. This particular signal, clearly we can say that this is a real signal. Nothing complex is involved here. So this is a real signal. and this is symmetrical about y-axis. So this is real and even. So x of t is real and even symmetric. So according to the Hermitian table, if your signal is real and even symmetric, then in frequency domain also the nature will be same. For real and even symmetric signal, when you fold the Fourier series by conjugation property, it is Cn conjugate or Cn equal to C minus n conjugate. Okay. So folding in time domain corresponds to what we say conjugation in frequency domain. So when the signal is real, C of minus n and Cn conjugate will be equal. Correct? So they have mentioned C minus n equal to Cn conjugate. So statement number 1 is true. This Fourier series Cn is purely real. Yes, as per the property, it is real by Hermitian table. So Cn is purely imaginary. This condition is strike out, cancelled. See the fourth statement. The magnitude spectrum of x of t exhibits an even symmetry. Of course, the magnitude spectrum, when you take the magnitude, C of minus n will be equal to C of n, correct? So even symmetry will be maintained. So 1, 2 and 4 are correct. Which of the statements are or true? So this is wrong. 1 to 4, 1 to 4 is wrong. 1 to 4. Yes, so we can clearly say that option C is the correct answer. The question is giving you an opportunity to think, recall, just have a recap of all the concepts. The first 6 points of the 8-point DFT of a real valued sequence are 5, 1 minus J3, 0, 3 minus J4, 0 and 3 plus J4. Okay. The last 2 points for students for a real valued sequence x of n. See, if you are having a signal x of n, then its n point DFT is denoted by x of k. Okay. If x of n is real, then x of k will be equal to x of n minus k conjugate, correct? X of n minus k conjugate. Say yes or no. Or x of n minus k will be equal to x of k conjugate. Now see here. X of 0 is 5. X of 1 is 1 minus J3. X of 2 is 0. X of 3 is 3 minus J4. X of 4 is 0. X of 5 is 3 plus J4. Comfortable, students? X of k is conjugate. See, what's your name? Chinmay. They already mentioned that the signal is real. So when the signal is real, then this properties, conjugation properties reduced to these statements. Chinmay, x of k will be x of n minus k conjugate and x of n minus k will be x of k conjugate. Now we want x of 6. X of 6 will be x of n minus 6 conjugate. It means x of 2 conjugate. और x of 2 conjugate कितना होगा? X of 2 is here. 0 conjugate will be 0. X of 7 will be x of 8 minus 7 conjugate. That is x of 1 conjugate. So x of 1 conjugate will be 1 plus j3. Yes. Watch it carefully. Next. The frequency response of a causal and stable LTI system is given. Okay. So students, clearly we can write, we can split this in the form of its magnitude and phase. So students, theta omega is the phase angle of h of j omega. Numerator's phase minus denominator's phase. So it is minus tan inverse omega by 1, and again since denominator is there, so minus tan inverse omega. So theta omega is minus 2 tan inverse omega. So what do you mean by group delay? Group delay is Tg. It is minus d by d omega theta omega. So minus 2 is out, so it will become plus 2. So 2 upon 1 plus omega square. Okay, so this is the answer. If they ask you the phase delay, which is not asked here, it is minus theta omega upon omega. So minus of minus 2 plus 2 tan inverse omega upon omega. This is phase delay. So minus 2 is coming out, minus minus plus 2, and derivative of tan inverse omega is, फॉर्मूले में भी तो माइनस साइन होता है, देयर इज माइनस साइन इन द फॉर्मूला आल्सो, माइनस ऑफ minus 2 plus 2, derivative of tan inverse omega is 1 upon 1 plus omega square. Minus of minus 2 will become plus 2. Option A is the correct answer. Students, All India Open Mega Mock Test for GATE 2023, 24th Jan to 30th Jan. You can register for this on our app. Students, GATE 2023 live exam analysis on 4th and 5th Feb on this particular channel. So 1 p.m. and 6 p.m. Next. Next question. Yes, Ravi, they will schedule it. It means our team will schedule it and we'll discuss the solutions in a separate session on app. For a discrete time sequence x of n 3421, 0 pointer is positioned at 3. We want the convolution between x of n minus 1 and x of n plus 1. X of n minus 1 means delay. Students, always remember, I have utilized this, I have said this sentence in my various classes. When a signal shifts right side on the graph, 0 pointer shifts left side. So x of n minus 1 means my signal is shifting right side by 1 unit. 0 pointer will move left side. Left side. So this is x of n minus 1. What about x of n plus 1? Yes. So x of n plus 1 means advance. Advance means signal will shift left side. 0 pointer will move right side. 0 pointer will appear at 4. X of n minus 1 on graph, signal will shift right. 0 pointer will move left. So if this pointer is moving to the left side, then there will be an additional 0 here. X of n plus 1 means advance. On graph, signal will shift left, but 0 pointer will move 1 bit right side. Ravi is asking, if there is x of n minus 2, then what? Then it will shift 1 more position left. So there will be 0, 0, 3, 4, 2, 1. Got it? This is x of n minus 1 and x of n plus 1. Now, zero, 3, 4, 2, 1. And 3, 4, 2, 1. At last, we will decide the 0 pointer. Huh? Don't worry. Multiply it. 3 into 0, 0. 3 3s are 9. 3 4s are 12. 3 2s are 6. 3 1s are 3. 4 into 0, 0. 4 3s are 12. 4 4s are 16. 4 2s are 8. And 4 1s are 4. See, any one signal in the horizontal manner and another signal in the vertical manner. Now, 2 into 0 is 0. 2 3s are 6. Multiply this. 2 4s are 8. 2 2s are 4. Yes, Ravi. 2 1s are 2. Like this. And 1, not 1, 0. 1 into 3 is 3. Yes, either ways. This can be taken in column form also, and this can be taken in row form also. 0 3 4 2 1. Now the time for grouping. Means we are drawing the diagonals. Now, y of n is the result of convolution. So 0, then 0 plus 9 is 9, 12 plus 12 is 24, 6 and 16 is 22, plus 6 28, 19 plus 3 is 22, then we have 12, then 4 and then finally 1. Now see here, convolution is commutative. Yes, Muleshwaran, correct beta. Now see here, just count the positions. See, count the sequence also. Just you can count the sequence. So our answer is starting from 0, but in the options, their answer is starting from 9. So just follow this sequence first: 9, 24, 28, 22. First check these values. First check the numerical values: 9, 24, 28, 9, 24, 28, 22, 12, 4, 1, 22, 12, 4, 1. So out of option A and option D, there could be the correct answer. Now you check, you justify. See, if I count the 0th position in this, okay, this is your first position, okay, 0, and this is -1, this is -1, okay, this is -1, this is 0, this is n equal to 0, and this is n equal to -1. So n equal to 0 and n equal to -1 count together will give you n equal to -1. So this is coming at n equal to -1. It means 0 pointer will come over here. It means my signal is starting from 9. No need, if the first sample is 0, no need to write it. Okay, so our 0th sample is available at 9. Sorry, 0th sample is 9. 9, 24. This will be the correct answer. And what about this one? In this case, this is n equal to -3, then n equal to -2, then n equal to -1, and then n equal to 0. So this is wrong. See here, in x of n minus 1, this position first sample is n equal to 0. Here the first sample is n equal to -1. Just add the lower limits of both of these. 0 and -1 will give you -1. N equal to -1. N equal to -1. Of course, this is n equal to 0. Got it? Come on, respond fast. Ensure hitting the like button. If you have not done so, I request all of you to hit the like button. Ashok, n minus 1 means delay. On graph, delay means shifting right. In sequence, delay means 0 pointer where it should move. Delay means it should move left side. So it should move left side by 1 unit. So on the left there is nothing. So we have inserted a 0 and placed our 0 pointer here. X of n plus 1 means advance. Advance means 0 pointer will move right side. 0 pointer is moved to the next position. Ashok, this was for you. Then see this signal. X of n is 1 by 3 raised to mod n. Minus 1 by 2 raised to n u of n. Okay, students, we have to just analyze this mod function here. When it is right sided, n is positive, so it should be multiplied by u of n. So 1 by 3 raised to n u of n. When n is negative, this mod n will open as minus n. And since n is negative, it means it represents left sided. So 1 by 3 raised to minus 1 minus n multiplied by u of minus n minus 1. So these two terms are the result of this first term, and this minus 1 by 2 raised to n u of n as it is. Understood everyone? Now students, 1 by 3 can be written as 3 to the power minus 1. So if I write 1 by 3 as 3, then minus n will become plus n. That's it. Take the Z transform. Z transform of a raised to n u of n, it is Z upon Z minus a. For left sided signal, Z transform will be negative, minus Z upon Z minus a. This is right sided, so answer will be Z upon Z minus a. Now, individual ROCs R1, R2, R3. So mod of Z, u of n means greater than the pole value. Mod of Z, it is left sided, so less than 3. This is right sided, so mod of Z greater than 1 by 2. So students, this is our real axis. This is the imaginary axis, means this is overall Z plane. So we have got 3 poles, 1 by 3, 1 by 2 and 3. 1 by 3, 1 by 2 and 3. This is 1 by 3. Then we have 1 by 2. And 3 is the largest pole. Now see here. Mod Z greater than 1 by 3 means outside this. Okay, now you can see I guess. Mod Z greater than 1 by 3 means this region. This region. Then mod Z less than 3. Mod Z less than 3 means inside 3. Then mod Z greater than 1 by 2. So the common region is between 1 by 2 and 3. This is the ROC. 1 by 2 and 3. Next. Next question. See this one. For the discrete time system shown in the figure, the poles of the system transfer function are located at. Okay. So first of all, with the help of this diagram, we will be generating the input-output relation. See here. This is y of n. Z inverse represent a 1 unit delay. So after this delay, what is the signal available at this node? Signal available at this node will be y of n delayed by 1 unit, which is y of n minus 1. Again it is passed through 1 unit delay. So y of n minus 1 after 1 unit delay here, this will be y of n minus 2. Y of n minus 2 is passed through this multiplier minus 1 by 6. So signal here will be minus 1 by 6 y of n minus 2. Okay, now this y of n minus 1 is passed through this multiplier 5 by 6. So signal available here is 5 by 6 y of n minus 1. Very good. Now student, at this adder what is happening? X of n is coming and this signal is also coming. So here signal is x of n minus 1 by 6 y of n minus 2. So these two signals are available at this position. Okay. Now this is the input to this adder. So this adder is adding this component and the output will be y of n. So bachcha log, y of n will be addition of these two, x of n minus 1 by 6 y of n minus 2. Ravi, Z inverse component represents delay in the digital filter. Z inverse represents what? Delay of 1 unit. Whenever you see this block is providing the delay of 1 unit to the input. Minus 1 by 6 y of n minus 2. This component added with this component plus 5 by 6 y of n minus 1. Now see here. Bring all the y terms to the one side. Y of n plus 1 by 6 y of n minus 2 minus 5 by 6 y of n minus 1 plus 1 by 6 y of n minus 2 equal to x of n. All of you got it? Taking z transform both sides. So z transform of y of n is y of z minus 5 by 6. Z transform of y of n minus 1 is z to the power minus 1 y of z plus 1 by 6 y of n minus 2. Its z transform is z raised to minus 2 y of z. Z transform of x of n is x of z. So y of z is taken common, 1 minus 5 by 6 z to the power minus 1 plus 1 by 6 z to the power minus 2 equal to x of z. We want to know the poles in this system. So y of z is divided by x of z. So this is 1 upon, bring this bracket in the denominator, 1 minus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. So this is nothing but h of z, transfer function. So if you just take this negative powers to the denominator, then 6z square will be the denominator, that will come in the numerator. So 6z square into 1 will be 6z square. Then this is 5 by 6z. 1z will appear in numerator. So minus 5z and plus 1. So this is the denominator. So students, 6z square will be factors 3z minus 1 and 2z minus 1. Just multiply these two. So 3z into 2z is 6z square. Minus 3z minus 2z is minus 5z. And minus 1 into minus 1 plus 1. So after simplifying the denominator, after equating the denominator to 0, you will get two poles equal to 1 by 3 and z equal to 1 by 2. So option C. Not only for control system, for any electrical circuit you can have transfer function, right? That can be an amplifier, that can be control system, that can be any other circuit. You can have the transfer function. A system is described by the differential equation. Let x of t be the rectangular pulse given by this signal, x of t. So students, first of all, will write this equation in the form of dashes. So d2y by dt square is y double dash t. Many times I have taken this, but this is an important variety. 5 y dash t. That's why I'm saying that we need to convert this into Laplace domain. That is always the easiest part. So 6y of t equal to x of t. Now what is x of t? X of t is a rectangular pulse in the interval 0 to 2. So u of t minus u of t minus 2. Now take the Laplace. Take the Laplace. So Laplace of y double dash t, if all initial conditions are set to 0, Laplace of y double dash t is s square y of s. Laplace of 5y dash t, 5s y of s. Laplace of 6y of t, 6y of s. Laplace of x of t is x of s. You can just take the Laplace of this right hand side, u of t 1 by s. U of t minus 2, it is e raised to minus 2s by s. Initial conditions are 0. Initial conditions are all 0. Now, if you take y of s common, then what is remaining? S square plus 5s plus 6. 1 minus e raised to minus 2s by s. So y of s is the Laplace transform of output. You can factorize this term, right? इसके factors कर सकते हैं, s plus 2 and s plus 3. Okay, sir. S square plus 5s plus 6. Okay. So this is the answer. 1 minus e raised to minus 2s, s plus 2, s plus 3. Oh, option B is the correct answer. See, a signal is represented by x of t equal to 1 and 0 for mod of t less than 1 and mod of t greater than 1. Okay. So amplitude is 1 and the width is from minus 1 to plus 1. This is nothing but x of t. Okay. Student, if you closely observe, this is the expanded version of rect signal. So if you just double the width of, rect signal, you will get this signal. Means it is rect of t by 2. Okay, sir. This is not rect signal. This is the expanded version of rect signal. So rect signal is expanded by 2 times. Got it? This is rect of t by 2. Now listen. For rect t, Fourier transform is 2 by omega sine omega by 2. If you just time scale it by factor of 1 by 2, if you time scale it by factor of 1 by 2, if you time scale it by factor of 1 by 2, then Fourier transform will be 1 upon a x of omega by a. Got it? Simplified. So 2, this is 2 upon 2 omega, 2 to cancel. 2 upon 2 omega. Sine 2 omega by 2. Sine 2 omega by 2. Okay, sir. So 2 to cancel. 1, 2 is there, omega is there, and sine omega is there. So this is the Fourier transform of x of t. Okay. Now what can be done? Now see, x of t is having Fourier transform 2 by omega sine omega. This is very much clear to all of you. Now, you have got two signals, x of 2t and x of t by 2. Okay, sir. X of 2t, 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 x of 2t. So if you just time scale it by a factor of 2, so rect t will be the answer. X of 2t will be rect t, and for rect t already we have the Fourier transform as 2 by omega sine omega by 2. This is our one result. Then we need x of t by 2. X of t is having Fourier transform by omega sine omega. By omega sine omega. This is the Fourier transform of x of t. If you are doing time scaling by factor of 1 by 2, you will get x of t by 2. So Fourier transform, see, 1 upon a, 1 upon 1 by 2 will be 2. With 2 upon omega upon 1 by 2 will be 2 omega. Sine omega upon 1 by 2 will be again 2 omega. This is 2 to cancel, 2 by omega sine 2 omega. Now, our y of t is x of 2t convolution of x of t by 2. So its Fourier transform will be, हाँ जी, what is the first result? x of 2t का result कितना है? 2 by omega sine omega by 2. Convolution is converted to multiplication, and x of t by 2 का result of x of t by 2 transform, Fourier transform, 2 by omega sine 2 omega. So final answer is 2 2s are 4 upon omega square sine omega by 2 into sine 2 omega. Just enclose this answer into your eyes. 4 by omega square sine omega by 2 sine 2 omega. Oh, lots of love. Yes, Ravi, I have derived this result, first one, in all my classes. Got it? Then next. Yes, everyone respond. Understood this one? All of you got this? This is the last 11th question in this session. Thanks for your response, students. See this question. Consider the parallel combination of consider the parallel combination of a lot of revision is necessary. You need to keep the concepts isolated, revise them also isolated. So parallel combination of two LTI system is shown here. H1T and H2T. These are the two systems connected in parallel. So what is the net impulse response of this system? Net impulse response will be the addition of the individual impulse responses. H1T plus H2T. Okay. Addition of these two. इन दोनों को add कर लो. You will get net impulse response. So H of T will be 2 delta T plus 2 minus 3 delta T plus 1 and H2T is delta T minus 2. Now, x of t is unit step signal. X of t is given as u of t. Okay, sir? Now, x of t is u of t. They are asking for the output's energy. The student output is x of t convolution with h of t. So u of t convolution with h of t. H of t has got these three terms: 2 delta t plus 2 minus 3 delta t plus 1 plus delta t minus 2. Okay. Now you can separate this. Apply the linearity property. So u of t convolution with 2 is coming up front, delta t plus 2. Then minus 3 u of t convolution with delta t plus 1 then plus u of t convolution with delta t minus 2. Now listen carefully. Whenever a signal is convolved with the impulse, so whenever you convolve this signal with delta t, the answer is this signal. So 2 times u of t. But don't close the bracket, because before closing the bracket you need to do the net shifting here. So here shifting is 0, here shifting is plus 2. So put a plus 2 here. Minus, see this signal convolved with delta. So whenever a signal convolved with delta, adjacent signal will be appearing as it is. Baju wala signal as it is aa jayega. Don't close the bracket. Apply the net shifting. Here shifting is 0. Here it is plus 1. Make it plus 1. And u of t convolution with delta t. Again u of t. Don't close the bracket. Net shifting is minus 2. Wow. So this is my output. Very good. So I need to plot this signal on the graph. See here. So there is a step at minus 2, then minus 1 and plus 2. Okay. At minus 2, what is the amplitude? 2. So here there will be step rise of 2 units. This will be continued to the next level, minus 1. At minus 1, what is happening? Coefficient is minus 3. So there is a step fall of 3 units. I'm not getting responses here. What happened? 3 units fall. So this height is 2. 3 units fall means fall of 2 unit and further 1 unit fall. Fall of 2 unit and further 1 unit fall. Okay. And this height will be continued to the next level 2. And at 2 there is a, see, coefficient is 1. It means there is a rise of 1 unit. Wow. So this is 0, this is 1 and this is minus 1. Okay. So this is your graph of y of t, correct? Bolo bachcha, this height is 2 and this height is minus 1. Bolo bhai, samajh mein aaya? This is the graph of y of t. Okay. Now what you need? You need energy. You need energy. I also need energy. So energy is integration from minus infinity to infinity. Y of t modulus square dt. So minus 2 to minus 1, one part of integration, 2 square dt. Then minus 1 to 2, another part. Here amplitude is minus 1. So minus 1 square dt. Now everyone can solve this. So 2 square is 4. Integration of 1 is t. Minus 2 to minus 1. Minus 1 square is 1. Integration of 1 is t. Minus 1 to 2. 4 times. Minus 1, lower limits minus and minus 2, plus 2. 2 minus of minus 1, 2 plus 1. So 4 plus 3, 7 times, yes, 7 joules. 7 joules will be the net energy. So what is the status now? Students, this was the 11th question. So thanks a lot for coming to this session. Wish you all the best for your upcoming exams. Do join tomorrow's session. Tomorrow, students, 10 a.m. tomorrow. I will be coming live with my team, Ashutosh Sir, Rakesh Sir, and Sridhar Sir. Yes, Ashok, I will be forwarding the PDF of this session on my Telegram group. Students, I hope you're all the part of my Telegram group. I'm just sharing the link of my Telegram group here once again, so that if you are not the part, you just join this, find my Telegram group. Okay, sir. तो ये आ गए हम वापस. Ravi, best wishes from the entire BYJU'S team and from my side. I have just shared my Telegram group here. I request all of you to join my Telegram group so that you can collect the PDF. Students, let's meet tomorrow at 10 a.m. for engineering, maths, and general aptitude. Of course, verbal will be there. So thanks a lot for coming to this session. Thank you so much. Thank you so much. Before this, students, just go through this GATE and ECE test series, full length mock subject test. Link is given in the description box. You can take the advantage of this. These are the various features of the test series: 60 plus test, detailed mock analysis, utility of the virtual calculator. This test series is of course curated by GATE experts, and all India open mocks. Mock tests are available for India level. Ravi, just try to do the justice to your weaker part as well. You can definitely do miracles. And 4,000 practice questions will be there in this test series. Students, don't forget to subscribe our channel if you have not done so. Hit the like button if you have not done so. Share the link in all your contacts, and of course download the BYJU'S Exam Prep app. So thanks a lot, students. Jai Hind, Jai Bharat. Good night.